lifeless place on Earth is hiding something alive. Not just alive, but something that shouldn't exist at all. Antarctica is supposed to be simple. A frozen desert. Colder than Mars. Drier than the Sahara. Nothing grows here. Nothing survives here. At least, that's what we've always believed. But recently, deep beneath miles of ancient ice, scientists detected something impossible. Not a rock formation, not trapped air. Movement, and not the kind caused by shifting ice or melting water. Something organized. Something active. Now imagine this. You're standing on the surface of Antarctica. Beneath your feet is nearly 4 kilometers of ice. That's taller than Mount Everest is high from base camp. And under that, total darkness, crushing pressure, temperatures that should freeze anything solid. And yet, something down there is breaking the rules. The deeper scientists look, the less Antarctica behaves like a frozen grave, and more like a sealed world. A world that has been hidden for millions of years. And what they're finding is only the beginning. For decades, Antarctica was treated like the end of the story, a place where life stops. No sunlight for months. Winds that can strip exposed skin in minutes. Temperatures plunging below -80 degrees Celsius, cold enough to freeze steel brittle. By every rule we understand about life on Earth, this place should be empty. But that assumption hides a flaw. Because Antarctica isn't just a surface, it's a layered world. And the deeper you go, the less those rules seem to apply. Scientists once believed that anything buried beneath the ice would be frozen solid,
to the modern cellular
locked in
structures.
time like insects
This
in amber.
visualization is key.
But when radar technology began scanning below the surface, it revealed something no one expected. Not solid ice, but liquid water. Entire lakes. Not 1 or 2, but hundreds. Hidden beneath kilometers of ice, these lakes are completely sealed off from the outside world. No sunlight, no air, no connection to the ecosystems above. Some of them have been isolated for over 15 million years. Think about that. That's older than early human ancestors. Older than entire mountain ranges. These lakes existed before we even existed as a species. And yet, they're not frozen. Which raises a question that shouldn't have an answer. If there is liquid water, in total darkness, cut off from the world for millions of years, what could possibly be living inside it? At first, scientists assumed the answer was simple. Nothing. But then, they started finding signals, chemical traces that didn't make sense, patterns that hinted at activity, and most unsettling of all, signs that something down there wasn't just surviving, it was thriving. And that's when Antarctica stopped being a frozen wasteland and started becoming something far more disturbing. Because if life can exist there, then maybe we've misunderstood where life can exist at all. And this is where the descent truly begins. The first lake they chose wasn't random. It was the largest, the darkest, and the most isolated place ever discovered beneath the ice. Lake Vostok, buried under nearly 4 kilometers of solid Antarctic ice. This lake is so deep, so sealed off, it has never seen sunlight. Not once in over 15 million years. To reach it, scientists had to do something that had never been done before. Drill. Straight down. But not just through ice, through time. Each layer of ice is like a frozen record. Snowfall compressed.
Initiating
year
the drill
after
sequence
year,
now. Let's go
century
deeper.
after
Roger
century.
that. Monitoring
As the
systems are
drill
stable.
moved deeper,
Depth
it
increasing
passed through
steadily,
ice that
century
fell
after
before
century.
human civilization. Before agriculture. Before modern humans even existed. You're not just going down, you're going backward. And the deeper the drill went, the more dangerous it became. Because this wasn't just exploration, it was contamination risk. If even a single microbe from the surface slipped into that lake, it could destroy an ecosystem that had been isolated since before humans walked the earth. So they slowed
Slow it down.
everything
Let's be
down.
cautious.
Acknowledge,
Ultra-clean
slowing to half
drilling
speed.
fluids,
Good. Keep monitoring
sterilized
the pressure.
equipment,
Levels are
extreme
stabilizing.
precautions.
Excellent. Proceed.
Because whatever was down there, they only had one chance to see it as it truly was. Finally, after years of effort, the drill broke through. But not in the way anyone expected. Instead of water rushing upward, something else happened. The pressure from the lake forced water up into the borehole, where it instantly froze, trapping whatever it carried inside the ice. A perfect sample, untouched, sealed. When scientists extracted that ice and began analyzing it, they expected almost nothing, maybe a few simple microbes at best. And instead, they found something that made no sense: genetic material, not just from one organism, but from many. Hundreds of distinct DNA signatures, some resembling known bacteria, others completely unrecognizable, like fragments of a biological language we've never seen before. And then came the most unsettling detail of all. Some of those genetic sequences were closer to organisms that normally live in the guts of animals. Animals that shouldn't exist anywhere near that environment. Which leads to a question that scientists still can't fully answer. If this lake has been sealed for millions of years, what were those organisms feeding on? Because something was sustaining them. And whatever that something is, it lies deeper still. At first, scientists thought they were dealing with a paradox. A lake that shouldn't be liquid. An ecosystem that shouldn't exist. Energy where there should be none. Because without sunlight, life has a fuel. No photosynthesis, no plants, no food chain as we understand it. So where's the energy coming from? The answer doesn't come from above. It comes from below. Far beneath the ice, under the lake itself, the Earth is not frozen. It's alive. Antarctica sits on a complex, restless crust, and in some regions, heat from the planet's interior slowly rises upward. Not enough to melt the surface, but enough to warm the water trapped beneath the ice, like a hidden stove, burning in total darkness. And where there's heat, there's chemistry. Minerals from the Earth's crust dissolve into the water. Iron, sulfur, hydrogen. To us, these are just elements. But to certain forms of life, they are food. Instead of using sunlight, these organisms use chemical energy, a process called chemosynthesis. Imagine living in a world with no light, where your only source of energy comes from slowly reacting minerals in the dark. It sounds alien, but it's real. Entire ecosystems on Earth already survive this way, deep in the ocean, near hydrothermal vents. Creatures that feed on heat and chemistry, thriving where sunlight never reaches. But here's what makes Antarctica different. Those deep-sea ecosystems still connect, indirectly, to the surface world. Nutrients circulate, energy flows. Lake Vostok doesn't. It's been sealed, completely isolated, a closed system, which means everything inside it had to survive, evolve, and adapt without any outside help for millions of years. Now imagine that. An ecosystem cut off from the rest of Earth for longer than human evolution itself. What happens to life in that kind of isolation? Does it stay the same? Or does it become something else entirely? Because the deeper scientists looked into the data, the more it felt like they weren't just studying life. They were studying a version of life that had taken a completely different path. And that path may lead somewhere we're not prepared to understand. At first, the data looked like noise, fragments of DNA, incomplete sequences, tiny biological signatures buried in ice, easy to dismiss. But the more scientists analyzed the samples from Lake Vostok, the clearer the pattern became. This wasn't random. This was an ecosystem. Not large, not visible to the naked eye, but alive and active. They found microorganisms capable of surviving in conditions that would kill almost anything on the surface. No sunlight, near-freezing water, crushing pressure. And yet, these organisms weren't just enduring, they were adapting. Some appeared to feed on iron, others on sulfur. Instead of breathing oxygen like we do, they used chemical reactions to generate energy. It's like living without air, without light, without warmth, and still finding a way to exist. But then the data became stranger. Among the genetic sequences were traces that didn't fully match any known species on Earth, not just new variations, but completely unknown branches of life. Imagine finding a word in a language that doesn't belong to any alphabet we've ever seen. That's what this looked like. And then came the detail that made scientists pause. Some sequences resembled those found in complex, multicellular organisms, not just bacteria. Something more advanced. Now, that doesn't mean there are giant creatures swimming beneath the ice, but it does suggest something unsettling. The ecosystem may be far more complex than a simple microbial world, because complexity requires stability, time, energy, balance. And Lake Vostok has had all three for millions of years, which leads to a possibility that's difficult to ignore. What if this isn't just a collection of microbes, but the foundation of a hidden food chain? A system where life feeds on life, in total darkness. And if that's true, then something at the top of that system must exist. Something we haven't seen. Something we haven't reached. Because so far, scientists have only touched the surface of what lies beneath Antarctica. They haven't explored the lake directly. They haven't seen it with their own eyes. All they have are fragments, clues, signals from a world that doesn't behave like the one we know. And as new expeditions push deeper into other subglacial lakes, into buried rivers beneath the ice, they're beginning to find something even more disturbing. Lake Vostok might not be unique, not even close. At first, Lake Vostok was treated like an anomaly, a single hidden lake, a strange accident beneath the ice. But then the radar maps expanded, and everything changed. What scientists saw next wasn't a lake, it was a system. Dozens, then hundreds, of subglacial lakes scattered beneath Antarctica, some small, some vast, all buried under kilometers of ice. But the real discovery wasn't their number, it was how they were connected. Because these lakes aren't isolated, they're linked by hidden rivers, slow-moving channels of water flowing through complete darkness, a network, invisible from the surface, silent, ancient. Imagine standing on Antarctica again, beneath your feet, not just one lake, but an entire hydrological system, stretching across the continent, like veins under skin, water moving, pressure shifting, entire lakes filling, then draining. Over timescales we can barely measure. Some of these lakes can empty and refill over the course of months or years, without any sign on the surface. No sound, no cracks, no warning, just movement, deep below. And where there is movement, there is exchange. Nutrients, microorganisms, energy, which means something critical. This hidden world is not static. It's alive, in motion. Now imagine what that does to life down there. Instead of a single sealed ecosystem, you have connected environments, different conditions, different chemistry, different pressures, like isolated islands, suddenly linked by shifting currents. And when ecosystems connect, they evolve faster. They compete, they adapt, they change. Some organisms spread, others disappear, and some become something entirely new. Scientists began detecting chemical signals moving between lakes, traces of life, traveling, which raises a possibility far more complex than anyone expected. What if this isn't just life surviving in isolation, but life interacting across an entire hidden continent, a biosphere, one that has existed beneath Antarctica for millions of years, completely unnoticed? And here's where it gets even more unsettling. Because this network doesn't just connect lakes, it connects environments that vary dramatically in temperature, pressure, and chemistry. Some regions are colder than others. Some are richer in minerals. Some may even be influenced by geothermal hotspots far below, which means somewhere in that network, conditions could exist that are far more extreme than anything found in Lake Vostok. And if life has adapted to those conditions, then we're no longer talking about simple organisms. We're talking about life that has evolved under pressures we don't fully understand. Life that may operate on rules different from our own. And the deeper scientists look into this network, the more one question begins to surface. If something is moving through these hidden rivers, what else might be moving with it? Because in a system this vast, this connected, nothing stays small forever. And the next discovery would push that idea to a level no one was prepared for. At first, it didn't look like a discovery, just data. Subtle shifts in the movement of water beneath the ice, the kind of readings scientists see every day. Easy to ignore. But then, the patterns began to repeat. Not randomly, predictably, almost like a pulse. Deep within the subglacial network, certain lakes were filling and draining in ways that didn't fully match known models. The timing was off, too consistent in some places, and too sudden in others, as if something was influencing the flow, not just geology, but behavior. Now, to be clear, no one is saying there's something alive pushing water through Antarctica, but the data forced a difficult question. Why would a natural system behave with this level of coordination? Because coordination implies connection, and connection implies response. Scientists began placing more sensors, more satellites, more ways to listen to what was happening below. And what they found next only deepened the mystery. In certain regions, they detected rapid drainage events, entire lakes losing massive volumes of water in a matter of days. To put that into perspective, imagine a body of water the size of a city, emptying silently, beneath kilometers of ice. No earthquakes, no surface collapse, just disappearance. And then, elsewhere in the network, another lake would begin to rise, as if the water had been redirected, flowing through hidden channels we still can't fully map. Now, imagine experiencing that from below. If you were inside that system, the pressure changes, the sudden movement of water, the shifting chemistry. It wouldn't feel like a slow environment. It would feel dynamic, unstable, alive. And this is where things become difficult to ignore. Because when environments change rapidly, life doesn't just adapt. It evolves under stress, faster,